G'day, today I'll be talking to you about the theory of special relativity, Albert Einstein. Einstein's special theory of relativity, published in 1905, was based on two postulates. 1. The laws of physics are the same for all frames of referencing moving at a constant velocity with respect to each other. For example, a spaceship cannot measure its own speed relative to empty space, but only relative to other objects. 2. The free space velocity, or speed of light, c, is constant for all observers, independent of their state of motion. c equals to 3 times 10 to the power of 8 meters per second. Spacetime. Traveling through spacetime. When you stand still or you're traveling, it's through time. When you move a bit, then some of your travel is through time and through space. If you were able to travel at the speed of light, all your traveling would be through space, with no travel through time. Light travels through space only and is timeless. Special relativity features appear only when speed involved is close to the speed of light. Consequences of special relativity. Some of the consequences of special relativity are: events which are simultaneous to a stationary observer are not simultaneous to a moving observer. Nothing can move faster than c. The speed of light in vacuum. A stationary observer will see a moving clock running slow. A moving object will be contracted along its direction of motion. Mass can be shown to a frozen form of energy according to the relation E equals mc squared. Consequences of special relativity. Time dilation. Time may be affected by relative motion of observers. Consider a cart moving with velocity v under a mirrored ceiling. A light pulse travels to ceiling and back in time to for rider and in time for t for watcher. Einstein's time dilation equation, delta t equals to delta to over square root of 1 minus v squared divided by c squared. An example, ship A passes ship B with a relative velocity of 0.8 c, which is 80% of the velocity of light. A woman aboard ship B takes 4 seconds to walk the length of a ship. What time is recorded by the man in ship A? This can be shown in the equation delta t equals to 4.0 seconds over 1 minus 0.8 c squared over c squared, therefore equals to 4 seconds over square root of 1 minus 0.64, which therefore equals to delta t 6.67 seconds. Thought experiment. Consider time dilation for identical twins. One takes high-speed round-trip journey while the other stays at home on Earth. When the travelling twin returns, he is younger than the stay-at-home twin. How much younger depends on the relative speed involved. If the travelling twin maintains a speed of 87%, the speed of light for a year, then 2 years will have elapsed on Earth. At 99.5% speed of light, 10 Earth years would pass in one spaceship year. At this speed, the travelling twin would age a Sid year, while the stay-at-home twin age 10 years. Explanation: special relativity is only valid for inertial frames of references, which is stationary or moving with a constant velocity. The travelling twin motion was not uniform. Acceleration and forces were needed to go to and from space. The time and space seems to move slowly than on Earth. He is in a non-inertial frame of reference, hence he will be younger upon his return. The Earth twin, on the other hand, remains in the same inertial frame of reference, hence older. Experimental evidence of time dilation. Decaying muons. Muons are particles produced by cosmic radiation, have a life of 2.2 US. If they move at a speed of 0.99 c, the max distance a muon can travel is 600 meters. But muons travel 4,800 meters. How? Due to time dilation. Consider the two reference frames, the Earth frame and the Moon reference frame. The time measured by an observer is the proper time, since only one clock attached to the muons is required. An observer in the Earth frame needs 2 clocks. Earth frame, because of the time dilation, the lifetime of a muon is longer as measured by an observer in the Earth by a factor v-7.1. Decay time in Earth frame t equals 16 US. Hence available time equals 0.99 c times 16 US equals 4,800 meters. Muon frame. In the muon frame, the muon c, a shorter length, travelled 600 meters. Consequences of special relativity. Relative simultaneity. The judgment of simultaneous events is also a matter of relativity. Consider observer 1 sitting on top of a moving train, while observer 2 is on the ground. A train is moving with a velocity of v to the right when it ends up being struck by lightning. At t equals 0, lightning strikes train and ground at A and B. The light from strikes A and B reaches observer 2 at the same time. Since the distance traveled by the light is the same, observer 2 sees lightning events A and B as simultaneous. Observer 1 says event B occurs before event A, due to motion of train and the lightning strikes the right side first. Thoughts on relative simultaneity. The thought experiment for relative simultaneity is also related to the previous slide. The previous slide explains how the theory of relative simultaneity is shown as the train is going at fast speed, so the person in the train sees the lightning one at a time than the person standing at the platform due to relative simultaneity. This is because the person in the train is moving towards the first lightning, so therefore he sees the lightning strike happen one after another. As for the person standing on the platform, he sees both lightning at the same time. Thought experiments versus reality. Most of Einstein's theories are based on abstract thought experiments. The idea of time dilation and relative simultaneity are deduced based on thought experiments involving trains, lightning, etc., as demonstrated in previous slides. Thought experiments may deviate from reality stem from. In the time dilation thought experiment on the identical twins, it is not possible in reality to really differentiate the varying ages. In the relative simultaneity thought experiment, in order to observe any noticeable effects, the train needs to be infinitely longer. This cannot be in reality achieved, as the observer will not be able to see the lightning flashes from both ends of the long train due to infinitely large distances, which will result in the light intensity dropping to 0 before reaching the observer. Implications of time dilation. Traveling through space at a very fast speed into interstellar places greater than 10 light years, the time dilation for Earth has made much significantly. A shuttle moving at 0.9 the speed of light traveling 10 light years. Therefore, the time dilation on Earth has aged for 500 years, as for the traveller, which has only aged 20 years. This is shown in the equation below that I have done. Implications of relative simultaneity. Future implications of relative simultaneity is that traveling through space, the navigation pinpoint of satellites may see a different event, therefore making the navigation unreliable and not trustworthy. Reliable and valid sources. Through the use of my textbook and university websites, I can therefore say that my information is reliable and valid. This is because these websites are very trustworthy and have been written by professors. My secondary sources were physics in focus textbook and other exercise books. Thank you for listening to my presentation, and I hope it gave you a better understanding of the special theory of relativity.